Now that we've seen how to collect the data, let's look at how we would actually put the data in the lab notebook. This lab has more computations, has more derivations than we normally have. Everything I have, this is online as always. All of this information I want you to write down. You will not be required to derive these items, but you'll work problems where understanding this process will help you do the problem. I will not give you these formulas on the test because they're too confusing. People will wind up using the wrong formula. If you remember them, if you want to memorize them, you're welcome to do that. But what I really want you to do is understand how to do the process. And for most of you, when you plug the numbers in, the process will look simpler than it does when I do all letters. Okay, so my diagram that I have in my notebook shows the mass of the cart and this mass. If I assume no friction, the only forces I have acting, I have a total mass on this whole, both masses together. I have a force of gravity pulling to the right. The pulley changes the direction of the force. And I have a horizontal force pulling down the ramp. If I assume no friction, my net force is the force of gravity minus my horizontal force. But net force is always the mass times acceleration. So I put those two together and I get the Fg minus Fh equals m1 plus m2a, and then I just plug in my formulas for force of gravity and force horizontal from previous labs, and I work out the details, and I get this formula for my acceleration. Notice we're assuming when I write my net force, positive means my force of gravity is bigger, which means if you have a positive acceleration, you're going up the ramp. If you go down the ramp, this would turn out to be negative. Then I have to set up I'm going to include friction now. If I'm going up the ramp, this means the actual cart is going up the ramp. My friction is opposing that, so it's going to the left, and I have my horizontal force pulling to the left, and I have this force to the right. So my net force is equal to the force of gravity minus the force of friction minus the horizontal force. And then again, you plug all the numbers in and you get that. You can simplify this, but for the purposes of our lab, you can just plug your numbers in here. If the cart is going down the ramp, then the force of friction is actually helping my force of gravity. So it changes the sign, and my formula is similar, but there's a sign difference in the formula. So in this case, my net force is force of gravity plus friction is helping me minus the horizontal force, which is pulling me down. So that you can just copy down. Your table looks like this. We're going to do 12 trials. There are M1. I'm not going to make you weigh all these and get these exact, but since it's just one thing to weigh the cart that you're using, and that will go all the way down here. I just put in 0.507 on these last four because that's the one I used. Then I'm going to show you how to calculate this A equals 0 means there's a certain mass that gives me an acceleration of 0 in theory. And then we can use for this theory, for the theoretical acceleration, we use the formula from up here. This is what actually you measured off the LabQuest, and you remember earlier in the lab, in the video, that was the number that was on the LabQuest that I put in here. And in this case, this is actually real data. So I got within 5.7%, so I would assume you guys would be under 10%. And then I used, in this case, I had a negative acceleration, so I was going down the ramp, so I had to use the friction formula, for down the ramp, which was right here. So I did not have room for all that on one page, so I flipped to the next page and I show my work for this wasn't row 1 for me because that's not the data I did the first time. So my acceleration is 0 when m2 minus m1 sine of theta is 0. You can tell that from right here. Acceleration is 0 when the top's 0, and multiplying by g doesn't matter. So all you need to do is find m2. When m2 is equal to m1 sine of theta, it should be 0. So I just plug my numbers in. Here's my theoretical formula. Again, I just plugged the numbers in from the other side, and that's where this theoretical number came. And the negative means I'm going down the ramp. Then I did my percentage difference like we've done about 3,000 times this year. Down the ramp, my formula, this A right here is your measured A, not your theoretical. Because if you put your theoretical in here, you're going to get a force of friction of 0, because that's what we assumed. So you just plug all the numbers in. It's a simple plug and chug problem. And for me, I got 0.029 newtons. And I will find it interesting to see how the force of friction changes with the different angles and different masses. And again, those numbers would just go into the table. So this lab, collecting the data, once you get used to it, probably shouldn't take very long. I did my 4 pieces of data in about 5 minutes, so it'll probably take you 10-15 minutes, because once you get the hang of it, it'll go pretty fast. And then again, as always, you can divvy this up. You could say have one person do the theoretical for these 4, one for the next 4, and one for the next 4. Everybody should do some of each. That way you learn more, and it'll help you when you do the worksheets. Good luck.